All right, guys, we're going to look at the graphing quadratic functions practice in Alex. So let's look at the first one. All right, so it says graph the parabola y equals 2x squared, plot 5 points. So remember, whenever you want to graph, you want to start off with a table, x and y table, and we need to know what number starts off the center of the table. That center number is called the vertex for a parabola, or absolute value is called the vertex. So we want to plot the vertex and then 2 points to the left of the vertex and 2 points to the right. And that's what we always have done. The vertex is going to go here, and then we're going to count up and down and get 2 points to the left and to the right. So that's why we do 2 up and down. All right, so first we need to know what number starts our x section. So you always want to look at the equation, look for the x section. Usually it's going to be in some type of parentheses, absolute value bar, something. X will be bounded. If not, then the parentheses are around the x right here. So in this case, there's nothing inside the parentheses with the x. So this one starts off at 0 because there's no parentheses here. So x is in there by itself. Let me get my eraser tool and erase right there. All right, so x is in there by itself. So once we know what number it starts off, we count up and down. So counting up, counting down. But we're just going to go ahead and plug in and do 5 rounds of PEMDAS. The thing to be mindful with quadratics, the PEMDAS can be confusing if you do not start with your variables. So let's say I throw 2 in. So I have a 2 already that's there in the equation. And then it says x. So I open a parentheses, put the number in for x. X is 2. This is x, and then squared. So that's what it is, 2, and then x is 2, and then squared. PEMDAS says we do inside the parentheses. There's nothing to do inside the parentheses right now. And then we square it. When you square something, you take that number and multiply it to itself. So it's 2 squared, which means 2 times itself, 2 times 2. 2 times 2 is 4. And then we'll multiply by the 2 that was on the outside. So 2 times 4 gives us 8. So the whole thing here is 8. So if you do this out of order and take the 2 and multiply it with the other 2 first and get 4, then square it, 4 times 4 will give you 16. You've messed up the whole PEMDAS. So make sure you take x and square it, meaning whatever it was, multiply it to itself, and then we'll multiply it by the number out here. So let's say I take 1. If 1 went in, I would take 1, multiply it to itself. 1 times 1 is 1. Then multiply that by 2. 1 times 2 is 2. If I take 0, put it in. 0 squared is 0 times 0, which is 0. And then 0 times 2 is 0. If -1 went in, so I'm going to show this one. So 2 in parentheses, -1 goes in for the x, and then I square it. So first you square, take -1 and square it. Means take -1, multiply it to itself. So -1 times -1. Negative times a negative is a positive. 1 times 1 is 1. So +1. Then I multiply that by 2 and get 2. So when I put -1 in, it gave me 2. The negative multiplied to itself and became positive. And the same thing with -2. If we put a -2, I'm going to switch the +2 into a -2. So -2 squared means -2 times -2. Take the number and multiply it to itself. So -2 times -2 gives me +4. Then +4 times 2 gives me 8. So whenever we're doing these quadratics and graphing these parabolas, we should have the same symmetry like how we had with the absolute values. If you start from the correct center number, as you move away from the center or the vertex, you should get the same values as you move away. That's how you know if you're right. So if you're wrong, you're not going to get this. If you didn't start from the correct center number, you're not going to get this. So definitely check for that. Lastly, we just need to plot the points. You can use the plot a point button and just type these in, or you can grab the pencil tool. I'm going to use the pencil tool this time. So I have 2, 8, 1, 2, 0, 0, -1, 2, and then -2, 8. So I plotted all the points, and then we click the graph a function button to connect. And you see we have our U shape. Whenever we're doing an equation that has x squared in it, it should be U-shaped. Absolute values were V-shaped. Quadratics are U-shaped. All right, so we have another one here. Plot 5 points. We need the vertex. So we make a table. It says graph. So I'm making a table. What number do we start on? We always look for the x section. Notice I don't see any parentheses or anything. So that means the x section is just right here. So whatever number makes inside of this 0, that's where we need to start. So x needs to be 0. This one starts off at 0 as well. So we count up and down. We're going to do our 5 rounds of PEMDAS. Let's throw 2 in first. So it will be 2 squared plus 1, like this. 2 squared means take 2, multiply it to itself. So 2 times 2 is 4, plus 1. 4 plus 1 is 5. When I put 1 in, 1 squared. 1 times 1 is 1. 1 plus 1 is 2. So remember, whenever you square the number, to take the number, multiply it to itself. If x is 0, 0 squared. 0 times 0 is 0. 0 plus 1 is 1. Negative 1 squared. Negative 1 times negative 1 is positive 1. 1 plus 1 is 2. And then lastly, negative 2 goes in. Put it here. Negative 2 times negative 2 gives me positive 4. And then positive 4 plus 1 is 5. We have our table. We just need to plot our points. So we have 2, 5, 1, 2, 0, 1, negative 1, 2, and negative 2, 5. And then we connect with the graph function button. There it is. Check it out and move on to the next problem. All right, same thing here. We need a table, X and Y table. We need to know where to start. It says graph, 5 points. Okay, we're gonna get those 5 points, including the vertex. That's the number in the center. All right, so we need to know what number is this supposed to start on. So now notice we have parentheses now. So the X needs to be the number that makes the inside of this X section 0. So X will need to be positive 2, because if X is positive 2, this will say 2 minus 2, and 2 minus 2 is 0. So this one starts off at positive 2 for me. And once I know what number goes in the center, the vertex number X, I count up and down. So it gives me 2, 3, and 4. And then counting down will be 1 and 0. 4, 3, 2, 1, 0. Needs to flow. I have my 5 points, and the center one is the vertex. 2 above, to the left, and the right. All right. So if I put 4 in, we're going to run the PEMDAS. So remember, PEMDAS works with parentheses first. So if X became a 4, it will look like this. I replace the X with the 4, and then I subtract 2. And then all of this is squared, and plus 1. So how it'll work out is I do 4 minus 2 first. You do inside the parentheses first, then you do the exponent. So 4 minus 2 would give me 2 inside of there. And then 2 was squared, which means I take 2, multiply it to itself. So 2 times 2 is 4, plus 1 was 5. So if I do 3 and put it in, it'll be 3 minus 2 first, which gives me 1. And then all that was squared. So 1 squared, take 1, multiply it to itself. 1 times 1 is 1, plus 1 gives me 1 plus 1 is 2. If I put 2 in, 2 minus 2 is 0. 0 squared, 0 times 0 is 0. 0 plus 1 is 1. 1 goes in, so it's 1 minus 2, which is negative 1. Negative 1 squared means negative 1 times negative 1. Negative 1 times negative 1 is positive 1. 1 plus 1 is 2. 0 goes in for X. 0 minus 2 is negative 2. Negative 2 squared means negative 2 multiplied to itself. So negative 2 times negative 2. That's positive 4. And then 4 plus 1 is 5. Notice we have our symmetry. So more than likely, we are correct here. We started from the correct center number. That's the number that made 0. And we'll plug these in. So I'm going to use my pencil tool. So I have 4, 5, 3, 2. Oh, that's the wrong point. 3, 2. We have 2, 1, 1, 2, and 0, 5. And we hit the graph function button, connects it, and we move on. All right, so this type is going to be the type that we talked about in class, where we have x equals negative b over 2a. So remember, we always start our center of our table with the center of the graph, and we want whatever number makes the x section 0. But we have two x's. There's an x that's squared and there's a regular x. And these x's cannot be combined. They're not like terms because x squared is different from a regular x. So we'll need to use something, a formula that lets us know where the center is so we can make our table. So x equals negative b over 2a tells us the x coordinate of the vertex. And a, b, and c, a is always the number in front of the x squared term. So it's ax squared plus bx plus c. So you'll know what a, b, and c are. A is always the number that's in front of the x squared term, the x with the exponent. Whatever number is multiplied to that, that's a. B is the number in front of the x that does not have the exponent. And then c is the other number that's there that's not multiplied to the x or the x squared. So a in this case is 1. Because the x squared, I don't see a number in front, but there's always a 1 in front of a variable that doesn't have a number multiplied to it. So a is 1, b is 10. The number in front of the x that does not have the exponent is 10. And then c is 22. We're not going to need c for this one, but c is always the y-intercept. So it's nice to know. It's very quick to find. So c is the y-intercept if you wanted to know that. So let's find the x coordinate of the vertex by plugging it into this formula. X equals negative b over 2a. So x equals, we have the negative sign from the formula, then it says b. So I'm gonna open a parentheses, and it said b was 10. So I'm gonna put a 10 in for b. And it's over, and we have 2 from the formula, and then a is 1. So I close the parentheses, open parentheses, put a 1 in for a, and we get this. So negative, and then 10 in parentheses makes negative 10, because this is really negative 1 times 10, which gives me negative 10, because you could put a 1 in front of this parentheses. Parentheses works just like a variable that you multiply to. And then 2 times 1 is just 2. So we have negative 10 divided by 2, which gives us negative 5. So the x coordinate of the vertex is negative 5. We have negative 5 in the center. This is the vertex. And we count up and down from there. So counting up from negative 5 is negative 4 and negative 3. Counting down is negative 6 and negative 7. So it flows negative 3, negative 4, negative 5, negative 6, negative 7. Now we're going to also still need to do 5 rounds of PEMDAS. And this PEMDAS is going to be a little bit more intense because we're going to have to plug in the variable for x in 2 different spots. So let's make sure we do that correctly. So I'm going to put negative 3 in. So the first one, we put negative 3 in for the x squared. So it says x, so I put in negative 3. I close, then we raise it to the second power. Then it says plus, then it says 10, then it says x. So I open a parentheses and x is negative 3. And then it says plus 22. So now I need to PEMDAS this. So negative 3 squared means negative 3 times itself. So negative 3 times negative 3, which gives me positive 9. 10 times negative 3 is negative 30. And then it says plus 22. So I can work this in any way I want. I can do 9 minus 30, which is negative 21, plus 22. Negative 21 plus 22 is positive 1, because you could always flip this around and do 22 minus 21. So that just gives us 1. So we have when we plugged in negative 3. Let's do negative 4. So negative 4 would go in. So it's negative 4 squared plus 10 times negative 4 plus 22. So negative 4 squared is negative 4 times negative 4. That gives me a positive 16. 10 times negative 4 is negative 40 plus 22. 22 plus 16 is 38. And then 38 minus 40 gives me -2. So this gives me 38, and I take away 40. Remember, your elementary school teacher says you can't do that. So that means it's negative, and then 40 minus 38 is 2. So that gives me -2. All right, so I'm going to do one more, and then I'm going to use the fact that this should be symmetrical to get me the other one, since it's so much work plugging these in. But let's plug in one more. So let's say -5 goes in. So it'll be -5 squared plus 10, and then x is -5 plus 22. -5 squared is -5 times -5, and that's +25. 10 times -5 is -50 plus 22. So 25 plus 22 is 47. So I have 47 minus 50. This is going to give me -3. All right, so assuming I got the first two, well, these are correct, and I did start from the correct center number, then -6 should also give me -2 for the symmetry, and -7 should give me 1. I could plug these in to check, but let's go ahead and make the graph because I'm confident in our math. So let's plot these points. So I have -3, 1. -3, 1 is here. -4, -2, right there. -5, -3, -6, -2, and then -7, 1. All right, we hit the graph of function button. It connects and graphs our parabola. We go ahead and check that out. All right, last type like this, same thing. We have two x's. We need to make a table, it says graph, but we need to know where to start our table. And since there's two x's, we're going to need to use the formula x equals -b over 2a. All right, so a is 3. The number in front of the x squared is right there. That's a. B is -6. And C is -3. We don't need C right now, but we'll use it for the y-intercept. C is always the y-intercept. So let me plug these in. So we have negative, and then B is -6. So I have negative, and then replacing the B with -6 over 2, and then A is 3. So -6, negative times a negative is a positive. So it gives me +6 over 6. 2 times 3 is 6. 6 divided by 6 is 1. So our x coordinate of our vertex is 1. So now that we know what number goes at the center of our table, we can count up and down to finish our table out in the x section, or the x side. Now we need to do our 3 rounds of PEMDAS. So let's throw 3 in very quickly. So I have 3, and then I open a parentheses. X is going to be 3 now. So both these x will turn into a 3. So it's 3 squared. That was x squared minus 6. And then it says x. So I open a parentheses and put a 3 in, minus 3. So let's simplify this. So 3 squared, 3 times 3 is 9. And then times this other 3 is 27. 6 times 3 is 18, so it gives me -18 minus 3. So this one winds up giving me -21, because -18 minus 3 becomes a bigger negative, so it's -21. So I have 27 minus 21, which gives me 6. Let's plug 2 in. 3, we have 2 squared minus 6 times 2 minus 3. 2 squared, it's 2 times 2, take the number, multiply it to itself, that's 4, and then 4 times 3 is 12. 2 times 6 is 12 minus 3. So we have 12 minus 12 minus 3. 12 minus 12 is 0. And 0 minus 3, since 0 is nothing, we just have -3. We'll do one more, and we'll use the fact that this is symmetrical to get everything else. So lastly, let's plug 1 in. So it'll be 3, and then x is going to be 1 squared minus 6. Then this other x is also going to be 1 minus 3. So first, 1 squared means take 1 and multiply it to itself. 1 times 1 is 1. 1 times 3 is 3. So this is 3. 1 times 6 is -6. And then minus 3. So 3 minus 3 is 0. So I can just cancel these out. And then I'm left with -6. I'm trusting my math. So since we know this is a parabola, it should be symmetrical. So this one should give us -3. And this one should give us 6 if we did not make a mistake. You could plug 0 and -1 in and check your work. 0 is pretty easy to do because that's going to be 0. This is going to be 0. -3 is -3. So that one makes sense. Let's plot these points in graph. 3, 6, 2, -3, 1, -6. And that's not -3. 0, -3. And lastly, we have -1, 6. Hit the graph a function button to connect. We move on. It says find the x-intercept and the coordinates of the vertex for the parabola y equals x squared plus 2x minus 35. If there's more than one x-intercept, separate them with commas. So let's go ahead and find the vertex, and the x-intercepts are going to be the numbers that make the whole thing equal 0. And we'll have to do this usually with factoring. But let's start with the vertex. So how we find the vertex is x equals -b over 2a. All right, so a is 1. B is 2, the number in front of the x that does not have the exponent. And C is -35, but we don't need C right now, but I'll still keep track of it. And then we'll plug in so we can find the x-coordinate of the vertex. So B is 2, so I get negative, and then B is 2 over 2, and A is 1. So -2, and 2 times 1 is 2. So -2 divided by 2 gives us -1. So the x-coordinate of our vertex is -1. And we're not making a whole table, but the x-coordinate of the vertex would normally go at the center of the table. To find the other part, the y part of the vertex, we'll need to take -1 and plug it in for all the x's in the original equation. So let's do that. So this first x will change into a -1. I got open parentheses, -1, and that was squared. Plus, there's a 2 from the equation. And then it says x, so I open the parentheses. X is -1 minus 35. So -1 squared, remember, whenever you square, you take that number and multiply it to itself. So -1 times -1 is +1. Then I have 2 times -1. Negative times a positive is a negative, so that gives me -2, and then minus 35. So 1 minus 2 is -1. And then minus 35 gives us -36. So the y coordinate of the vertex is -36. So the whole vertex is 1, -36. Now for the x-intercepts, we'll get more into factoring as the year progresses. I mean, we get to solving the quadratics, but the x-intercepts are the numbers When y is 0, what numbers are x? So you're trying to find the numbers that make the 0. So if we factor this, you're looking for two numbers that multiply to give you negative 35, but when you add them together, give you 2. So you're finding two numbers that multiply to give you c, and when you add them together, they give you b. So if we go through numbers that we know that multiply to give us negative 35, we have 5 and 7. Well, one of these will need to be positive and the other one negative. And since we have a positive 2, the 7 needs to be positive and the 5 needs to be negative. So this factors as x minus 5 and x plus 7. And then we just need to find the numbers that will make this one 0, and the numbers will make this x section 0. So the number for x that makes the first x section 0 is if x were 5. And then the number that makes the second x section 0 is if x were negative 7. So those are the two x-intercepts, 5 and negative 7. All right, I seem to have left off my negative 1. Let me put that back in there. All right, next one. It says, answer the question below about the quadratic function. Does the function have a minimum or maximum value? Where does the minimum or maximum value occur? What is the function's minimum or maximum value? All right, so all this is asking about is the vertex. So the vertex, if we have a parabola, there's two situations. We have a parabola where it's positive, smiley face, and the vertex is at the bottom. So if you have a smiley face, positive graph, that means A is a positive number. You're going to have a smiley face. This one has a minimum. The vertex is the minimum. Now, if we have a sad face, a negative parabola, like this, make it a sad face. That means that the vertex, which is right here, is the highest part of the graph. That makes it a maximum. So you have those two options. So looking at this one, my A, the number that's in front of the x squared, is positive. So if it's positive, that means I'm dealing with a smiley face, and a smiley face has a minimum. Where does the minimum value occur? The minimum value always occurs at the vertex's x coordinate. We know how to find the vertex's x coordinate with x equals negative b over 2a. So we just need to plug in A and B. So A is 3 and B is negative 30. So in my case, I'm going to have negative from the formula, and then B is negative 30. So negative 30 over, I have the 2 from the formula, and A is 3. So negative 30 gives me positive 30. The two negatives will cancel each other out like this, turn to a plus sign. It's positive 30. And then 2 times 3 is 6. 30 divided by 6 is 5. So x equals 5 is the x coordinate of the vertex. So that's where the maximum or minimum occurs. What is the function's minimum or maximum value is going to be the y coordinate of the vertex. So I need to take this x and plug it in for all the x's up here and get the y coordinate of the vertex. So let's do the PEMDAS. So I have 3, and this says x, which is 5. It was squared minus 30. And then it says x, so I put a parentheses, and x is 5. And then plus 73. So I'm going to do some PEMDAS. It says 5 squared. Remember, when you square, you take the number, multiply it to itself. So 5 times 5 is 25. And then I can do 25 times 3 is 75. And then I have 30 times 5 is 150. So it's negative 150. And then it says plus 73. So 75 minus 150 gives me negative 75 plus 73. gives me negative, because this one's bigger, -2. So the y coordinate of the vertex is -2, and that is the minimum value. Since I have a minimum, then -2 is the minimum value. All right, so we have the graph, we have the vertex -4, 3. It says state the domain and range of this. So remember, whenever we have a parabola, the domain is all real numbers, but how we can tell, domain goes left to right. As you read this graph from left to right, the first thing we hit is an arrow pointing left. It's pointing down also, but domain, we're just caring about the left and right aspect. It's pointing left. Pointing left is represented by -infinity. And then the furthest the right part of the whole graph, so it does all this and then point, the last thing that we see pointing right to the right is an arrow pointing right. So it goes from -infinity to +infinity. And another way of saying that is all real numbers. The domain is all real numbers. Now the range is from bottom to top. Where does it start? Where does it end? So the lowest part of this graph that we see, bottom to top, going from down to up, is an arrow pointing down. That is represented with -infinity. Arrow pointing down is -infinity. So it'll look like this. The highest part of this whole graph is right here. That's the highest part. And that's at 3. And 3 is included. So it would have a bracket. So this is our range. It goes from -infinity and it tops out at 3. So if I converted this into the regular number line, it would look like, let's put 0 here. And then I have 3 like this. Now I have a closed circle at 3 and it's going to the left. This means that y, because range is always y is less than or equal to 3, because you start off with -infinity and it stops at 3. So y is represented by everything that's here, is less than or equal to 3 because it's to the left of 3. All right, this one says find the range. All right, so remember, these are pretty easy. The range is the y value. So you'll either have the highest, maximum, or minimum is going to be your vertex. Your vertex's y value. So we need to find the vertex's y value. And once we have the vertex's y value, it's either going to be greater than y or less than y. If we have a positive, this is a negative, we have a positive parabola, the y values will all be greater than our vertex. So we'll have a vertex number and then y is going to be greater than or equal to the vertex. If it's negative and we have a maximum, then all of our y values will be less than or equal to our vertex number. So let's go ahead and find our vertex number. We can already tell this one is a positive. So it's going to wind up being y is greater than or equal to. And we just need to find our y coordinate of the vertex. So first, let's find the x coordinate of the vertex using x equals -b over 2a. So a is 2, b is 12, so it's going to be negative, and then b is 12 over 2 times 2. That gives me -12 over 4, and then -12 divides by 4 and gives me -3. So x equals -3 is the x coordinate of the vertex, and we care about the y coordinate of the vertex for the range. So let's plug -3 in for both of these x's. So it's 2 parentheses x turns into a -3 squared plus 12, x turns into a -3 plus 15. So first we start off with -3 squared, means take -3 and multiply it to itself. -3 times -3 is +9. 9 times 2 is 18. 12 times -3 is -36. Then we have plus 15. 15 plus 18 is 31. Sorry, 33. Sorry. Minus 36. This gives us -3. So the y-coordinate of the vertex is also -3. Since we know this is a smiley face like this, that means all of the y values are going to be greater than the vertex. So I just need to put the -3 right there. So all the y values are less than the vertex if it's negative. All the y values are greater than the vertex if it's a positive smiley face, because the vertex is either the maximum or the minimum. So I'm just going to go ahead and type this in. So we have this one, and our y values, because we're talking about the range, are all less than, greater than, or equal to 3. All right, our last problem here is a word problem, but they give us the equation, and it says, what is the minimum cost? So we were talking about X-ray machines and the cost. It says X is the number of machines, and C, or the Y value, is the cost. So we're trying to find the minimum cost. That's telling us we are trying to find the vertex's Y value. The first thing we need to do is find the X coordinate of the vertex. So that's going to be how many machines they make where the minimum exists. So X equals -b over 2a. And we just need to plug in. So A is 0.2 and B is -100. So I have negative, and then B is -100 over 2, and then A is 0.2. So this is going to give me 0.4 on the bottom. And then on the top, we get +100. So +100 divided by 0.4, we could move the decimals over, but don't forget you always have this calculator here. If you're lost, we're going to wind up using this calculator. So let me just show you how to use this right now. But we could move the decimals forward like this. So the decimal for 100 is right here. You would move it over by 1 and move this one over by 1. So you get 1,000 divided by 4, which gives you 250. So the X coordinate of our vertex is 250. So this represents 250 machines. And we need to find the cost, which means take all of these X's and replace them with 250. So 0.2, and then we have X, which is 250 squared minus 100. And then it says X, so we're going to plug in 250 and then plus 31,146. So this is one of the problems where you should be using a scientific calculator to do some of this strenuous solving or computing, because you have really big numbers, and squaring these out, it's going to take a lot of writing by hand to write these numbers out, and they're very big. So it's more tedious than it needs to be. When we have those short ones, then you don't necessarily need a calculator. But so let's just type all this in. So we got 0.2, and then I'm going to just type it in exactly how it looks. So I have 250, and then it was squared. So I have to find the exponent button. Where is that one? Right here. And I type to the second, then I need to come back down. So I'm just going to click over here, minus 100, 250, plus 31,146. I got 18,646. So this should be the Y value for the cost. And that's it.